Rates can be used to generate data sets, and these data sets can be graphed as coordinates or lines. For linear functions, another way of thinking of rate is as the slope of the line. In this video, we'll look at examples of graphs of linear functions from which we can calculate the rate of change using the slope formula. Let's start with an example. This graph shows the change in a launched rocket's speed over time. What is the rocket's acceleration? The points on this line show the speed of a rocket for any time t. So as the time values increase, so does the speed. The rate at which the speed changes is called acceleration. To calculate the acceleration, calculate this rate. To find the change in speed and change in time, find two coordinates on the graph, as shown here. We will use the coordinates 0, 0 and 487.9. The rate of change from one coordinate to another is found using the slope formula. These are the y-coordinates, and these are the x-coordinates. Let's designate these coordinates as x1 and y1. And let's designate these coordinates as x2 and y2. Let's plug these values into the slope formula. The y values go here, and the x values go here. These are the y values, and these are the x values. Simplify the numerator and denominator. We divide 7.9 by 480 to get an approximate value of 0.164583, and the units are kilometers per second squared, which are the appropriate units for acceleration. So the slope of the line is the acceleration of the rocket. Let's look at another example. This graph shows the increase in savings with monthly deposits after an initial deposit of $100. What is the rate of money added to the account each month? In this situation, we start with an initial value of $100, and then some unknown amount of money is added consistently each month. But the rate at which it's added is linear, as shown by the graph. To find the rate at which money is being added, find the slope of this line. We identify two coordinates, 0, 100, and 24, 700. The first coordinate is the amount of money at the start, $100. The second coordinate shows that after 24 months, the total amount added has been $700. Let's use the slope formula to find the rate. Let's designate these coordinates as x1 and y1. And let's designate these coordinates as x2 and y2. Let's plug these values into the slope formula. The y values go here, and the x values go here. Here are the y values, and here are the x values. Simplify the numerator and denominator. We divide 600 by 24 to get a value of 25. The units are dollars per month. So the slope of the line is the rate at which money is added to the account monthly. Let's look at a final example. This graph shows the payment schedule for a car that originally cost $20,000. What is the monthly car payment? Notice that the orientation for this graph is different from the others. The line points downward and going from left to right. This is an example of a decreasing linear function. It's decreasing because a car loan is being reduced on a monthly basis through car payments. The original price of the car is $20,000, and some monthly amount is paid to reduce the loan. We can find the amount of the monthly payment, the rate of payment, by finding the slope of the line. We find two coordinates, 0, 20,000, the original price of the car, and 24, 9,200, which is the amount left on the loan after 24 months. To find the rate, use the slope formula. Let's designate these coordinates as x1 and y1. And let's designate these coordinates as x2 and y2. Let's plug these values into the slope formula. The y values go here, and the x values go here. Here are the y values, and here are the x values. Simplify the numerator and denominator to get this. We divide 10,800 by 24 to get a value of negative 450. This negative value tells us that we're reducing the loan by a payment designated as a negative number. The negative value for slope also accounts for the orientation of the line in a downward direction in going from left to right. The units are dollars per month. So the negative slope of the line is the rate at which the loan is being paid down.